Question 1. List at least 3 characteristics of the student's t-distribution. Okay, well first off, it's still symmetric. It has a mean of 0, still very similar to the z-score. You can picture the normal probability applet. However, the exact shape depends on the degrees of freedom. So even though it'll keep its bell-shaped curve, the natural bell-shaped curve, how quick it jumps up or how slow it decreases, that is dependent upon the number of degrees of freedom. And in general, it has more area in the tails, and so it generally opens up a little wider than the z test normally does. So unfortunately, we're not going to be able to use the normal probability applet for the t distribution. Number 2, how many degrees of freedom generally does the t distribution have when it is used for inference for a single mean? Okay, this is really simple. The degrees of freedom is equal to the number of your sample size, or your n, minus 1. So if we have a sample size of 15, and then our degrees of freedom are 14. Sample size of 50, degrees of freedom 49. Question 3. What is the formula for the one sample t confidence interval? The confidence interval for mu when sigma is unknown. Okay, so this is going to change just a little bit from what we had before. But we still start out with our x bar, the population of our sample, and then we subtract. And this time it's going to be the little t star instead of the z. Okay, but we're still going to multiply it by the standard deviation, but now it's represented by s because it's the standard deviation of our sample instead of the sigma, which was the standard deviation of our population. And we still divide it by the square root of n. Okay. And then the other side of the confidence interval is just, as you know, is just the same with a plus instead of a minus. Okay? That becomes our confidence interval. Question 4. What are at least 2 differences between the one sample t confidence interval and the one sample z confidence interval we covered in lesson 10? The first difference is that sigma is not known. Okay, big difference there. We don't know what the population standard deviation is. Another thing is we compute a t-score from the student t-distribution rather than the z-distribution. And so basically we are not able to use the normal probability applet. And another possibility is that we now have to keep in mind the degrees of freedom, which is something we didn't have to worry about in the z-score. Question 5. When conducting a hypothesis test for a single mean with sigma unknown, what is the formula used to compute the sample test statistic? Okay, here again, very similar to the z, but with just a few minor changes. So we still have our x bar, and we still subtract our mu, but this time we divide by s, which is the standard deviation of our sample, and then square root of n still. Okay, so just a little bit different. Question 6. What are the assumptions that need to be met to conduct a hypothesis test for a single mean when sigma is unknown? Okay, in order to do this, we have to have a simple random sample again, and x bars need to be normally distributed. And here again, it's either has to be the central limit theorem, greater than 30 sample size, or we have to do a QQ plot to make sure that they're normally distributed. That concludes part 1. Question 1. What are the requirements for creating a 95% confidence t-interval? Okay, so here again, just like in lesson 1, it is a simple random sample from the population, and 2, that the x bars are normally distributed, which you can check either with the central limit theorem or the QQ plot. Question 2. Using your calculator or Excel, compute the sample mean and sample standard deviation for the 15 pieces of data you see in part 1. Okay, so we are going to come back over to our Excel. Okay. So if we come back to our quantitative descriptive statistics, we have our data here on the left-hand side, and remember that the mean is given right here, the 46.7, and the standard deviation of the sample is 8.3. Okay. All right, so question 3. This time, we're going to do our confidence interval using the t distribution. So a real quick reminder on what that looks like. It's x bar plus and minus the t times, which is that t-score that they'll give you in all of these problems, times the standard deviation of your sample divided by the square root of your sample size. Okay, so let's run through that real quick. So remember, our x bar in this case was 46.73. And we got that from the Excel, from question 2 in this part, in this assignment. And we are going to subtract that number, the number that's found in the question where it says the t-score for a 95% confidence interval from the t distribution with 14 degrees of freedom is 2.1448. Okay, times the standard deviation of our sample, which is 8.83, divided by the square root of our sample size, which is still 15. And then on the other side, it's the same thing, but just with a plus sign. Okay, hopefully that's pretty familiar up to this point. And as you type those into your calculator, you'll come out with the solution 41.8 and 51.6. All right. Question number 4. Now the only thing that changes here is that t-star number. Okay, so we go from 2.1448, and that becomes, just like it says there, that final number in the question, 2.9768. Okay, but the equation is still the same way. Remember, on the other side you have the same thing, but a plus sign. And as you type those into your calculator, you'll get 39.9 and 53.5. Question 5 will now use the software. So in order to use the software over here, we open up the quantitative inference procedure. And there in the bottom hand corner, we want to make sure that we have selected one sample t-test. And then we can copy and paste our data that we've already typed in. So I'm going to paste. I'm going to paste in our numbers. And there we have it. Okay. Now, if you'll notice, our confidence interval is found right there in the bottom right-hand corner of the page. The confidence interval from 41 to 51. Okay. And part B, the 99% confidence interval using the data above. So if we want to change the confidence level to 99, that's right here. And this confidence level, change that to 0.99. And we have a confidence interval of 39.9 to 53.5. Question 6. How does the margin of error of the 95% confidence interval compare to the 99% confidence interval? Okay, so the margin of error for the confidence interval is going to be smaller for the 95%, and it's going to be bigger for the 99%. And if you think about that, that makes sense, because if we are only going to be 95% sure that the true mean is found in between those numbers, then we can make it pretty small. But if we're going to be 99% sure, then we have to make it a little bit wider just to include those extra 4%. So remember, the more confident you are, the higher your confidence, the wider your confidence interval has to be. Question 7. We're going to work through this problem again. A. State the null and alternative hypothesis. Here again, we worked with this problem back in Lesson 9. And it says that the null hypothesis is 47, because that's the age of the national age average of those buying second homes. And the alternative is that it's different. And it's going to be two-tailed, because he simply wants to know is it different than the national average? B says compute the test statistic. First compare it using the formula and showing your work below, then check this test statistic by inputting the data into the software. Okay, so we are now going to work through this t-score. Okay, so remember our formula. We have our x bar, which is 46.73. And then we're going to minus our mu, which is 47. I'm not going to write down the original. Hopefully by this point you've figured out the standard formula. Divided by our sample standard deviation, which is 8.83, divided by the square root of our sample size, again 15. When we plug that into the calculator, we come out with negative 0.118. Okay, now if we come over here to the Excel to change our confidence interval back to 95, we change our hypothesis to not equal to, and our null is 47, and our t-value is right here. So remember, confidence 95, null hypothesis 47, and not equal to, which is two-tailed. We get a t-score of negative 0.117. Now that little error there, the little difference in 0.001 is okay. In all of the tests, as well as in all of the quizzes online, they have built that in so that you can be just a little bit for rounding errors. But there you go. Part C, state the degree of freedom. Now degrees of freedom, remember, are your sample size n minus 1. So we have a sample size of 15, therefore our degrees of freedom are 14. D, sketch the t-distribution and shade the area which represents the p-value. Okay, now technically we're not allowed to use the normal probability applet to find the actual numbers, but as far as just for distribution and how it looks, we're going to use it in this case. Okay. So we come over here to our normal probability applet, shading both outsides, and typing in 0.118. We get our shape that looks like that. And if we want to use our snippet or whatever tool we need to get a picture of that into our homework document. Okay, E, use your software to compute the p-value. Okay, so if we come back over here to our software, we're going to come to the quantitative inference procedure, and we get a p-value, as long as these are all entered correctly, we have a p-value of 0.908. It's a pretty big p-value. Now because that p-value is so large, we fail to reject the null. Because remember, if the p is low, we reject the null. But since it's not very low at all, we fail to reject the null. G, present your conclusion in an English sentence relating the result to the context of the problem. We have insufficient evidence to suggest that the average age of second home buyers in this area is different than the national average. So remember, we have insufficient evidence. We say insufficient because we are failing to reject, and then we just restate the alternative hypothesis.